Hey folks, problem number 4 asks us to redo problem number 3, but with a confidence interval. So they give us the same data and they say make a 95% confidence interval. So we talked about this in the previous section, 10.2. There was one problem in the homework and I solved it out for you in the helpful hint section. But what the point was if it's an alpha O5 two-tailed test, it's logically equivalent to a 95% confidence interval. See how those two numbers add up to 100%? So if it was alpha 0.10, that would be the same as a alpha 0.10 two-tailed test would be the same as a 90% confidence interval. They need to add up to 100. If it's not a two-tailed test, there is a shortcut. We'll talk about that later. But for right now, if it's a two-tailed test, just make sure those guys add up to 100. Okay, so we already have the data in our calculator from when we did problem number 3. So when they say make a 95% confidence interval, it should be pretty easy. So we go to so let's see, we want to do a confidence interval. So that would just be tests, and that's going to be a t interval. So just go down to t interval, hit enter. And we already have the data, so choose data. I have it in L1, frequency 1 because every number shows up once. Confidence level, make sure it's 95, enter, calculate. And so it constructs for me a confidence interval of 11.629, 12.081. So remember, what does this actually mean? We are 95% confident that the true mean fill is between those two values. Okay, so based upon that confidence interval, we're going to somehow reach the same statistical conclusion. So here's our confidence interval. What was our original null? Our original null was mu equal 12. Okay, mu equal 12. So here's the question. The number in our null, 12, is it in the interval? Yes. Okay, so it's probably an okay idea. If the number was not in the interval, we would say, oh, it's a bad idea. Let's reject it. But right now we say, oh, the number's in the interval. Okay, it's probably reasonable, so let's not reject this idea. Let's do not reject HO. Oh, just like we had right there, do not reject HO. So to oversimplify things, I ask the question, is 12 in the interval? Is 12 in the interval? Yes. Okay, so this idea is okay. Let's not reject it. Do not reject HO. Okay. So is 12 in your confidence interval? Yes. So therefore our statistical conclusion is do not reject HO. And we get all the same information. So once again, a confidence interval can be used as a shortcut to a hypothesis test. And then I'll try and find one from the homework where it's not a two-tailed test, where it's a one-tailed test, and we'll do something similar. Okay.